All right, econ friends, let's wrap up our discussion of elasticity with one final elasticity measurement. This one is called the cross-price elasticity of demand. Let's first define it, do a quick example, determine what the computations are used for, and figure out how this metric helps us in economics, okay? So the cross-price elasticity of demand, this is defined as a measure, as always, of how responsive quantity demanded of one good is to changes in the price of another product. So again, the cross price, cross meaning one good to another good, the cross price elasticity of demand is a measure of how responsive the quantity demanded of one good is to changes in the price of another product. To make this really easy in our computation, we're going to simply call items A or B. That'll be our two different items. Now, if you're ever giving these questions to solve for a question set or an exam, it's oftentimes easier to get away from A or B and just put in product names, and that way it makes more sense and it's easier to get through mentally. But for the purposes of our formula, we're going to say that cross-price elasticity of demand is equal to the percentage change in the quantity demanded of good A divided by the percentage change in the price of good B. Or as I have it right here, the elasticity cross-price coefficient is going to be equal to the percentage change in the quantity demanded of good A divided by the percentage change in the price of good B, okay? Let's do an example. This is real data that actually came from the power industry. Between 2008 and 2013, natural gas prices fell by 2/3 because of increased fracking. So between 2008 and 2013, new technologies allowed for fracking to evolve. That's a way of extracting energy. And as a result of that, natural gas prices fell by 2/3. So we're going to say that the price of natural gas fell by 2/3 or 67%. Electric power companies responded by switching from burning coal to burning natural gas. Electric power companies, they generate electricity by burning fossil fuels often. When these companies saw that natural gas prices fell, they switched away from burning coal and toward burning natural gas. In fact, the demand for coal fell by 17.5%. So we would say that the price of natural gas fell by 67%. And in response, the demand for coal fell by 17.5%. With that data, we can calculate the cross-price elasticity of demand. And again, on this one, your positive or negative sign is going to be important, so don't throw it away. The cross price is equal to the percent change in the quantity demanded of A divided by the percent change in the price of B. This is going to be equal to negative 17.5% divided by negative 67%. And this is going to be equal to 0.3. So given this real data in real energy markets, economists can calculate that the cross-price elasticity of demand in this particular market equals 0.3. What does it all mean? Well, once again, to interpret and classify this data and understand these coefficients, the positive and the negative signs are important. So don't throw them away. And the basic idea behind cross-price elasticity, this is what's going to allow us to determine if two particular goods are substitutes or complements or unrelated. Again, we touched on this already in our demand lecture. We know that subs and comps are particular types of goods, and that changes in the price of one of those goods will affect the demand curve for another good. So we've already had some exposure to how the change in the price of one item can affect the demand for another item. We're now formalizing it with this metric, okay? Remember, complements are two goods that are used together. And therefore, since they're used together for complements, the cross price elasticity is going to be negative. In other words, the elasticity cross price coefficient is going to be less than 0. Okay? And if you wanted to, you can go identify two items that are in fact complements and just go through the old demand analysis. Price of this goes up, what's going to happen as it works its way through to the demand for the other product. And you can figure out and confirm that for complements, the cross price elasticity is negative and your coefficient is less than 0. Substitutes, as you know, are goods that are used in place of each other. We believe in economics that the cross price elasticity for substitutes is going to be a positive number. And therefore, the coefficient, the elasticity cross price coefficient, is going to be, that was ugly, is going to be greater than 0. And again, to confirm this and to kind of work it out, just in your mind or on your notes, conceive of two items that are substitutes that can be used in place of each other and go through the old analysis. If the price of the item goes up, what's going to happen to the demand for the substitute? And you'll confirm this. And finally, we know that we have comps and that we have subs, but it is possible, depending on the data set, to have a situation where the cross price coefficient is equal to 0. This implies that the goods in question are completely unrelated. They're not subs, they're not comps, they're just totally unrelated. When I give you assessments on this material, I'm not going to talk about this one. I'm going to focus more on you interpreting this for comps and for subs, but I did, in the spirit of complete coverage, want to share with you that for some items, there's going to be a cross price of 0 because they're totally unrelated. And this, my friends, is our fourth and final metric, our fourth and final coefficient in the theory of elasticity. Thank you.